Hi, in this video I am going to create a subassembly of a retaining wall consists of three types of measurement. First of all, let's review the dimension of the retaining wall. Here is the typical cross section of the retaining wall. The retaining wall types depend on delta H. Delta H is the difference between the existing ground and the top of the retaining wall elevation. Okay, now for example, if we have delta H ranged between 3 to 4 meters, the type of retaining wall will be the second type, or type 2. The dimension will be H equal to 4, S equal to 0.3, B equal to 0.2, D equal to 0.5, W equal to 2.5, and T equal to 0.4. Let's jump back to subassembly. Let's create new file. From the packet settings, we name the retaining wall. Be careful, the space is not allowed in the between the words. You can write a description here and attach a help file to the file. I am going to attach an image file. My image file is located here. This is my image. I had created it in Photoshop. The image dimension is 128 by 128 pixel. Open it. In the input and output parameters, I am going to change the site default value to right, and from target parameters I am going to create target parameters, rename it to EG, existing ground. The type is surface, and preview value to -3. Okay, first of all, we have the upper limit and lower limit of the retaining wall. Let's back to the PDF file. Here, the lower limit of our retaining wall types is 2 meter. If the delta H is less than 2 meter, we do not need to create a retaining wall, and if the delta H is greater than 5 meters, we do not create a retaining wall and inform the user that there is an error, or the delta H is greater than the upper limit of our retaining wall. Let's jump back to Subassembly Composer. First of all, I am going to create an auxiliary point. This auxiliary point will be at the attachment point of the subassembly, and the second auxiliary point will be the projection of AP1. The projection from AP1 on the existing surface. So from type here, change the type to delta X on surface, and delta X is 0, and surface target will be EG. If I hit this button here, fit to screen, you will see the points created correctly here. Now I am going to create a variable. This variable will hold the difference of elevations, difference between the AP1 elevation and AP2 elevation. rename it to delta h, and variable type double, expression equal to ap1 dot y, which is the elevation of the ap1, minus ap2 dot y, the elevation of ap2. Now we had created or find the delta h. We need to make a decision. In this decision, I will say here dh. If the dh is less than 2 meter, we do not need to create the retaining wall. So I need to inform the user that this limit is under our lower limit of the retaining wall. The depth is less than lower limit of the retaining wall. Now if the delta h is greater than 2 meter or equal to it, I am going to make another decision to find the type of the retaining wall we need to create. Let's break this connection and reconnect the left side of the previous decision to the next decision, and in this decision I am going to write delta h is if the delta h is equal or less than to 3 meter. If so, we need to create a flowchart. In the new flowchart, I am going to create the type 1 of the retaining wall. The P1 will be the attachment point of the retaining wall, and the second point will be the wall height. The third point will be the remainder or the overall foundation width minus toe width and top width and B, which will equal to minus 1.5. Sorry, and we should write this value in the delta x. P4 will be the depth of the foundation, and P5 will be the overall width of the foundation, and P6 depth of the foundation, P7 will be 0.2 toe width, P8 wall height, the point P1 and P8 need to be connected by a link, and finally I am going to add a shape. Okay, the first type of the retaining wall had been created. Now I need to make another decision. Break this connection. If the delta H is greater than 3 meters, we need to make another decision to say DH if less or equal to 4 meter, we need to create type 2. Now I'm just going here to copy type 1 and paste it here, and connecting the right side of the decision to our newly created flowchart of the second type. And here the steps is the same step we had created for the first type. Now for this reason I am going to change the point reference and dimension quickly. Okay, to see the change we made for the second tab, we need to change the preview value of the existing ground to -4 and hit this button here. You see the change had been taken, but there's an error. Okay, here we need to change this to P16 to close the links. Now for the shape, just pick the inside the area. Now so we had created the second type and making another decision for the third type. Here delta H is less or equal to 5. We need to create the third type. Copy and paste it here. Connect the right side of the decision to the newly created flowchart and make the change of reference point and dimension quickly here. Okay, to see the change, let's change the value of the existing ground to -5, and you'll see the change here. let's co- let's create the shape for this type. Okay, this type has been created. So if the delta H is greater than the upper limit of our retaining wall, we need to inform the user that this depth is not suitable for creating these types of retaining wall. Right here, this depth is greater than the upper limit of the retaining wall. Now had created all the types of the retaining wall, we need to save it. Okay, now in the next video we will go to use this subassembly and see what we can do with it. Thank you.